Well, we want to show a couple of identities involving A and B. This is a do-over because we had some technical difficulties earlier. Here is your angle A, and here is your angle B. So now what we want to do is go out from this vertex all the way out to here, and we'll call this one unit. Why can we do that? Well, we make units that go with our system. This is what is going to be one in our diagram, 1 unit. And now what we want to do is drop a perpendicular from this endpoint to the line between the segment between angle A and angle B. The segment between angle A and angle B. We want to drop a perpendicular. So this might be close here. We put a box there. Now we're going to drop another perpendicular from this endpoint, from this vertex. Drop another perpendicular to the base. And this box goes here. Box indicates a right angle, and the box is between the legs. So let's look at the triangle with acute angle B. What's opposite B? Well, the hypotenuse of this triangle is 1. So this better be the sine of B. Why is that? Because sine is opposite over hypotenuse, opposite B over hypotenuse. And by the same reasoning, this adjacent side must be cosine of B. Now we want to extend this edge here, this line here. We extend it. This ruler has seen better days, but we'll be working with it. So we'll extend it here. Now, what we really want to do here is from this point, we want to draw a line parallel to the base. We can do that because from a point, not on a line, there's one and only one line parallel to the given line, which is the base. That would be equivalent to Euclid's fifth postulate, will be Playfair's postulate. So now this top and bottom line are lines. These lines are parallel. So if you this could be thought, this segment here could be thought of as a transversal. So interior angles on the same side of the transversal are supplementary. So that also has to be 90. because the angle, the other interior angle on this side of the transversal is 90, so they must add up to 180. Now, what we want to look at is we would really like to complete this diagram. That means we're going to make a rectangle here. So we're going to erect a perpendicular to the base at this vertex. Now, this is a perpendicular to the base, so this is 90 degrees, this is 90 degrees, this is 90 degrees. 3 right angles in a quadrilateral means that the fourth angle is also a right angle. If you have 3, you must have 4. So now what we want to do is label the sides and we'll basically be done. Since this is angle A and the hypotenuse is cosine of B, the adjacent side here is going to be the cosine of A times the cosine of B, because adjacent over hypotenuse must give you cosine of A. And the opposite side of this bottom right triangle has to be sine A cosine B. Why is that? Because opposite over hypotenuse, opposite A over hypotenuse has to be the sine of A. And these cosine B's are going to be canceling. Now over here, this angle is 90 minus A because the acute angles of a right triangle are complementary. Now this angle here has to also be A, has to be A. Why is that? Because at this vertex, the 3 angles at this vertex must add up to 180 degrees, because this side here is a straight line. Now, if the hypotenuse of this little triangle on the upper right is sine of B, this must be sine A sine B. Okay? Because opposite over hypotenuse has to give you the sine. And this over here has to be cosine of A sine B, because this adjacent to A over hypotenuse has to add up, has to divide out to cosine of A. adjacent over hypotenuse. Now, this angle here has to be, you have alternate interior angles. This here is A plus B. The top and the bottom are parallel. The top of the rectangle and the bottom of the rectangle are parallel. And you have a Z here, which indicates that you have alternate interior angles. Alternate interior angles are congruent. So now the hypotenuse of this triangle on the upper left, the hypotenuse is 1. So this is the sine of the angle. And this is the cosine of the angle. Now, since this is a rectangle, it is a rectangle, we know that opposite sides of a rectangle are congruent. This side on the left is congruent to this side on the right. The side on the left is the sine of A plus B. The side on the right is the sum of these two segments. It's sine A cosine B, and over here you get plus cosine A sine B. And if we look at the top and the bottom, we get at the top you have the sum of the two lengths, cosine of A plus B plus the sine A sine B. That must be equal to the bottom length. Now we can push this term to the right side. Once we do that, it becomes negative, a minus anyway. So we get cosine A cosine B minus sine A sine B. We push this to the other side. So that allows us to state the two formulas, the identities, the sine of the sum and the cosine of the sum. And that's basically that's what we're after here. We're after these two identities. So that's the end of that story.